Okay, so last one is Newton's backward difference, and we said Newton's forward difference and backward difference. The table will have the same values, but their position will be changed. So what is happening? You are given the same n plus 1 point with equal distance, and then at any point we are defining the backward difference as the current point minus the backward point. Okay, and then we are defining them, or we are denoting them as a nebula, which is an upside down triangle. Okay, so we are going to, first thing is you need to complete this table. This is what will be given for you. Okay, so you can have your x0, this is your x0, x1, x2 and x3. Okay, and then you have the corresponding y1, y2, y3 and y4. You want to find out the first backward difference. Okay, so if I say I want to calculate the backward difference, we said the backward difference is current value minus the backwarded value. So if I am here, I don't have a backward value, so I cannot have a backward difference at this position. If I am here, current value minus backward value is 1.0 minus 2.5, which is negative 1.5. If I am here, current value minus backward value 3.5 minus 1.0, which is 2.5. 1.5 minus 3.5, which is negative 2.5. So these are actually the same values. If you go back, you can see negative 1.5, 2.5 and negative 2. 1.5 minus 3.5 is negative 2. So they are the same value, but only difference is the position is changed. Okay, now we are going to calculate the second order difference, backward difference. So when we are at this position, we don't have any current value here, we don't have also a backward value. You cannot calculate at this point. Okay, when I am here, what is the position? At this position we have a current value, but we don't have a backward value. So you still cannot calculate backward difference at this position. When I am here, I have a current value minus I have a backward value. 2.5 minus negative 1.5, so that will make a 4. And then negative 2 minus 2.5, which will be negative 4.5. Okay, now I want to calculate the third order difference. So I cannot calculate at this position, next position, and this one also, because I have current position, current value, but I don't have a backward value. Only position where I can calculate is this one. So that will be negative 4.5 minus 4, which will be negative 8.5. Okay, and we said when we are using backward difference, we use the last table, sorry, last row of the table. So here is our last row of the table. We are going to use this one in the formula, and this formula works on, look at here, f of xn, that means your last point. So this is your xn, f of xn, first order difference at xn, second order difference at xn, and third order difference at xn. Okay, so right now we are going to use this table to calculate the values of f of 3.5, f of 6.5. In previous one we calculated 3.5, so we are going to calculate on this one. And again, what is your x? At any point you will write x using the last point. Okay, so if I want to find the value at 3.5, then what will happen? 3.5 is equal to, look at here, xn. What is your xn? Xn is 7.5, last point, plus s times your h is the common difference between the x. So 3 to 4.5, 4.5 to 6, this is 1.5. Okay, so minus 7.5 on both sides, and then 3.5 minus 7.5 is negative 4. negative 4 is equal to s times 1.5. You will divide both sides by 1.5. So that is giving you your s is equal to negative 4 divided by 1.5 is 2.66 something. So if you want to find out what is the function value at 3.5, you are going to use this formula. F of 3.5 is equal to, first thing you need to use is f of xn. Look at here, our f of xn is 1.5 plus s is negative 2.66 times first order difference. My first order difference is negative 2.0 plus s is negative 2.66 times s plus 1, negative 2.66 plus 1 divided by 2 factorial. Second order difference is negative 4.5. Okay, s is negative 2.66, s plus 1 is negative 2.66 plus 1, and then s plus 2 will be negative 2.66 plus 2 divided by 3 factorial, which is 6, times your third order difference, which is negative 8.5, times negative 8.5, and then you just need to plug them in your calculator properly, and that will give you the value at f of 3.5. So again, I am going to put those calculation in the handout. If you want to calculate what is the value at 6.5, so you need to write down your x is equal to 6.5. I'm just showing you an example how to calculate that x. So suppose I want to calculate at 6.5. So 6.5 is equal to xn. This is the formula. Xn plus sh. Your xn is 7.5 plus s times h is fixed 1.5. That's the difference between, what is h? H is the difference between 3.0 to 4.5, 4.5 to 6, 6.6 to 7.5. For forward difference and backward difference, this h is always fixed, right? For Lagrange interpolation and Newton's divided difference, we don't have that restriction of points need to be of equal distance. Okay, so right now we are trying to solve for a 7.5 minus 7.5 on both sides. So this is giving us a negative 1. Negative 1 is equal to s times 1.5. So we will divide both sides by 1.5. 1 divided by 1.5. So s is equal to 1 divided by 1.5, which is 0.666, negative 0.666. So what will you do is you will replace all these s. Everything else will be same, only s will change. All these s will be negative 0.666, and you will complete your calculation. So again, I'm going to complete the handout and I will upload it on Canvas handout, and you can complete your assignment.